So, DNA fingerprinting, you have a gel, and it's literally like a clear gel, like Jello. Yeah, it literally looks like Jello. And it has these little cuts in it, little wells we call them.
Can you see them?
Yes. It's little like cutout squares. And so what happens is you take DNA from something, put it into a mixture with restriction enzymes. So let's say we're doing a crime scene. So we find blood at the crime scene, and we take DNA from it and cut it with a restriction enzyme that cuts every time it sees AAA. Right? Then we have 3 different suspects. We put their DNA in the same thing, but we use the exact same restriction enzyme. That's important because there's no way of getting matches if you cut with different restriction enzymes, because you're looking for the patterns of the cuts, because on my DNA, AAA, that pattern is going to show up different than on your DNA. So the cuts are going to be different.
So they just use any random restriction enzyme?
Yeah.
Okay.
But they have to use the same one.
Okay.
So the pattern is the same.
Gotcha.
So let's say this is crime scene DNA. They dye it, and they actually get these colored bands that go across. And these bands, they go across due to their length, because they're putting an electrical charge through it, and they're actually attracted to the charge. So the DNA actually wants to travel that direction. The longer ones, though, get stuck early. The longer pieces. So let's say, here's my strand of DNA. Oh, there's an AA right there. Oh, there's another one. Oh, there's another one. Oh. It does like that. So there's different lengths of strands. So the longer ones can't go as far, the shorter ones can. So then you have 3 suspects, and...
So is that, is the marking how far it made into the gel?
Yeah, that's actual DNA. The actual DNA is the line, and that's as far as it got in the gel.
So that's how it shows up in the gel?
Yes, exactly. Okay, so here's our suspects. Which one would you say was at the crime scene? It's a little bit off. 3, yeah, it's a little bit off. This should be more like up here. Like that. Yeah, but that's exactly what they do. They go through and they find which one matches the closest, and because my DNA will only cut like my DNA. Your DNA will only cut the same as your DNA, because all of us are a little bit unique. So you do it, and they find this pattern. And the other suspects will share. Obviously, we're all humans, so we're going to share some patterns. So you may see, resemblance in other ones, but you look for which one's more exact.
So is that still how they do it today?
Mm-hmm. They'll still do that, yeah. And pregnancy tests, you can actually do it this way too. So let's say the first one's the baby. And then we have the mom and dad 1 or 2. We're trying to see who's the father. So
if they had, they found hair at a crime scene, but they didn't have the suspect, there's no way they could find out who it was just by having, a piece of hair, right?
By a piece of hair?
Yeah.
They can find out.
DNA, but I mean, if they have no suspects, they have no idea who did it, can they find out, whose hair that is?
It'd be hard. You have to have something to compare it to.
Go off. Okay.
So you'd have to at least
I feel in crime scene shows they just test this DNA, it's this person.
Well, some people are on file, it's like fingerprints. Some people have their fingerprints on file, so you can do it that way, but others aren't. So you have the baby, and then you have mom, you have 1 and 2. Which one do you think is the father? This was a little bit trickier. 1, why?
It's got the most matches.
Because when looking at the baby's DNA has to come from mom and dad. So what you do, you go, okay, that one's taken care of by mom. Oh, that one's taken care of there. That's taken care of by mom. That's taken care of there. See? Because the baby is a mixture of mom and dad. And so you're not looking for a complete match, you're looking for which one fills in the blanks better.
Interesting.
And so, there you go. That's
And that first one's called gel electrophoresis.
both are called gel.
Okay.
This whole process of putting DNA in these little wells and putting electricity through it and having them go across, that's gel electrophoresis.